So this video is an introduction to plastics, or polymers as they're properly termed. Now the majority of plastics obviously come from oil-based sources and are effectively hydrocarbons consisting of hydrogen and carbon, but many sort of natural plastics are becoming popular now, obviously to improve the longevity or sustainability of producing products, not relying on oil, using sources such as cornstarch and things like this. Now plastics are obviously very popular nowadays because now they've got manufacturing techniques to actually produce these things like injection molding. You can now produce very complicated shapes that have a lot of the properties of metals and things like this, where they might have been used, but obviously you get a lot of benefits from using plastics or polymers, and these are things like how light they can be, the fact that you can add colour and pigmentation, the requirement, well, the lowered requirement to finish the product, because obviously the mould, it can allow for self-finishing, and obviously they are obviously electrical and thermal insulators, which metal is not. So an example they talk about in the AQA book is obviously a kettle, and obviously you can imagine all the benefits that you get from this. I mean, you don't want a particularly heavy kettle, perhaps. You might want to produce a kettle in a range of different colourways to suit the person's kitchen, and obviously some of the complexity of the shape. If you want to make the product more ergonomic or more tactile, you can obviously do this, and obviously integrating things like elastomers as well as sort of thermoplastics in can obviously improve the sort of general feel of the product and things like this as well. So as I said, plastics mostly come from oil as a source, but obviously there are sort of plastics coming from sort of semi-synthetic polymers. So one example would be like cellulose or cellulose acetate, which obviously comes from sort of plant fibres and is mixed with acetic acid to produce cellulose acetate. And an example of the use of cellulose acetate is OHP. These are the overhead projector slides that people write on, prior to the use of overhead projectors in the more sort of electronic sense. Another example of a product coming from a sort of a regenerated source or a sort of a semi-synthetic source would be casein. Now this is actually coming from milk as a source, which seems unusual, but has always been used for many years in the manufacture of buttons, to attach a garment together and things like this. So as I said, but most plastics obviously come from sort of coal, oil and gas as the sources to create thermoplastics or plastics, and it's a process called thermal cracking. Now there are three general types of plastics that are used. Okay, the first I've discussed before is thermoplastics. Now the thing with thermoplastics is they're probably used for the widest range of products, and the benefit of thermoplastics is they can be heated and softened with the use of heat, and this becomes, improves their plasticity and malleability, so you can form them into shapes. However, if they are heated again, they will soften and can be formed again. Okay, and as I said, these produce many products from plastics. Okay, the other main group of plastics out of the three is thermosetting plastics. Now these differ from thermoplastics. They're not quite as flexible in terms of how you can manufacture these. Okay, so they're quite limited in terms of the products that you can make. Okay, and this is probably because they undergo a chemical change once they're first formed, and therefore they become permanently rigid. Now this has benefits, obviously. Now something like a electrical light switch, for example, if made from a thermoset plastic, it basically means that if there is an electrical failure or something, or heat is built up inside, the polymer is not going to melt and it's not going to burn as you'd find with maybe a thermoplastic, and it's got a slightly higher tolerance to heat than many thermoplastics do. However, they obviously do have thermoplastics that have higher heat tolerances, but this is probably one of the main uses for thermosetting plastics. Now plastics obviously have multitude of different properties, and there's many different plastics, and you choose plastics based on their individual properties. However, many plastics offer a set of properties that are generic to them all. They all have these sort of properties. Okay, now one of these is that plastics are good insulators of electricity and obviously of heat, thermal insulators as well. Okay, another example is they have a good strength to weight ratio. Now it doesn't mean that, you know, a plastic can be really strong, like steel is very strong, okay, but it means that for a very small quantity of the plastic, it's very strong compared to how much it weighs. Now if you think of casings for electrical products, they're actually quite stiff and they're actually quite strong, but if you look at the thickness of the product, it's actually very thin. Another example might be something like, if you compare it to say a tin foil or something like this, if you have a sheet of foil made from maybe aluminium, you could basically quite easily tear it, so the shear strength of that product is very low. However, if you had a very thin sheet of plastic, maybe PVC, and you was trying to tear that, the shear strength is much stronger, and it's obviously probably a product that weighs a lot less as well. Okay, so it has lots of strength to weight benefits for these sort of products, so you can use quite a small amount of material but create a material that is strong enough to produce, you know, a range of properties required for the products that you're actually producing. Now other benefits is they have good atmospheric and chemical corrosion resistance. So, you know, if you think about plastics, if we're making a product that's going to go outside, it's going to be subjected to rain. If we're thinking about something that is going to be used as a washing tool, maybe a washing up brush or something like this, we might have to use it with bleach, we might have to use it with other chemicals, okay? And plastics are very good because they can resist these sort of chemicals and obviously water, and to an extent oxidation and sunlight as well, through the use of additives that are added into the plastic process. Now the other benefit, although you could say perhaps it's a deficit with the example of thermoplastics, is they have quite low melting temperatures. Now this is going to make it then very easy for them to be moulded and processed through injection moulding and things like this. Generally they are lightweight, okay, this obviously relates to their strength to weight ratio as well, but they are lightweight for the amount that they're going to be used, and they can be self-coloured, they can come in opaque, as in they don't let any light through, translucent, letting some light, or transparent, like completely clear. So, you know, by adding colours into the actual process when you're injection moulding or your rotational moulding or something like this, you can produce a whole range of different colours to suit different needs. Okay, now the other advantage of plastics, similar to kind of metals in the way that you can treat metals with heat to kind of make them stronger or have different properties, okay, plastic can be improved by adding certain things in. Okay, so what we could do, for example, is if we wanted to bulk up the amount of plastic without using lots of costly polymer granules, is we can use fillers. Okay, so we could use things like sawdust, wood flour, crushed stones or something like this, and these could produce you know, more product, or increase things like the strength or the hardness of the polymer, or remove the brittleness so it doesn't sort of snap as easily under sort of tensile strength or something like this. You can add flame retardants, okay, so this can stop the plastic being so easy to combust or ignite, okay, so this could be helpful if you was making perhaps cushions for an upholstery product, or like a seat or a cushion or something like this, and it would stop the thing being so easy to ignite. Anti-static agents can be included to stop the build-up of electricity. I mean, if you've ever walked around in your lounge with a certain type of shoes on, you might find that you build up static electricity, and you know, this can be quite inconvenient and can cause problems in various different ways. Plasticizers can be added, so obviously plasticity of a material is its ability to flow, okay, especially when you're moulding or something like this, and it also is going to reduce the amount of temperature you're going to need to allow it to be moulded easily, and it might also make the product less brittle, so less likely to sort of snap under pressure and things like this. You can also add things called stabilizers, okay, and this could stop the product being so easily broken down or degraded by things like ultraviolet light, okay, because obviously you wouldn't want a plastic product, if it's going to be used outside, to be degraded so easily, or something perhaps that's going to be placed near a window, because obviously this could make the product prone to being more brittle, or to actually discolor the product over time. Okay, now there's obviously many applications for plastics, okay, and you know, this very much depends on exactly what you're doing, okay, but some examples would be sort of using PET, for example, polyethyl terephthalate, okay, to extend the shelf life of carbonated drinks, okay, because they're less permeable than some other polymers used as PVCs and things like this, okay. But obviously, being thermoplastics, they just have such a wide range of these different properties, and now they're starting to use them more because they can change the properties so much for very varied and different applications, okay. Now, most plastics, as we said, came from oil, okay, and one of the huge problems with using oil is obviously it's a finite resource, it's running out, but obviously it also has an impact on the planet. So the production in this way is eventually these oils are going to run out and make this a problem, okay. So a lot of research is going into obviously using biodegradable plastics, and the other benefit of using biodegradable plastics that come from natural sources is they will degrade and rot down over time, whereas a standard oil-based plastic might last, for example, 100 years if left on a landfill site, and this landfill will build up over years and then becomes another environmental problem, okay. Now, the applications for biodegradable plastics obviously is very good for things like packaging. So if we think shopping bags, drinks bottles, disposable pots that you might use in the garden to pot plants and things like this, and things like medical products, I don't know, like garments and stuff, or wound dressings where you want the product to be used once and then to be disposed, because what you don't want is to use the product once, throw it away, and then it actually can't degrade down and it sits on landfill or something like this. Whereas biodegradable products that often come from renewable sources, things like starch and like from wheat, corn and potatoes and things like this, can make things like, for example, a capsule for medicine, so it will degrade within your mouth or your stomach or something like this. Or it could make, you know, simple packaging so that it will last for the shelf life or the intended life of the product, and then when disposed it will degrade very quickly.